The other approach I will describe here is a breadth-first search. When using a breadth-first search, or BFS, we explore the graph by gradually increasing the number of hops from the initial vertex. Let us consider the same example, where we start in V1. We start by exploring all vertices one hop away from V1. We thus connect both V2 and V4 to V1. Then we explore all vertices 2 hops away from V1. A vertex 2 hops away from V1 is 1 hop away from a vertex that's 1 hop away from V1. So we look at the neighbors of V2 and V4 and connect them to V2 or V4. We obtain V3, V5 and V7. Then we explore the vertices 3 hops away from vertex V1. So we look at vertices 2 hops away, which are V3, V5 and V7, and at their unexplored neighbors. We obtain V8 and V6. Finally, the orange vertex is 1 hop away from V8, which is 3 hops away from V1. We connect them. The resulting graph in red is a spanning tree obtained from the BFS, which is made exclusively of shortest paths from vertex V1 to all the other vertices of the graph. A BFS is a cautious strategy in which we try to keep the distances to the initial vertex as small as possible during exploration. This is especially useful when the initial vertex contains specific resources that we might need at any moment. However, it does require more organization than its simpler DFS counterpart. In the previous example, the spanning trees obtained by a BFS and a DFS are very different. Here is another example using the graph we've considered earlier in this lesson. This is a spanning tree obtained from a DFS starting from V1, while this is a spanning tree obtained from a BFS starting from V1. Because a BFS is performed by gradually increasing the hops from V1, a spanning tree obtained from a BFS will always provide the shortest paths from V1 to any other vertex in the graph, provided that the graph is unweighted. This can be seen clearly in this example. In the next lesson, we will see how the difference between a BFS and a DFS directly relates to the type of memory structure that can be used to implement these two algorithms.